It's in continuation to previous video which is lost due to interruption of signal, so it's again quality issue. I am continuing with this mean not to repeat all. I was in some way on this point that I was talking of blinding. That's a checklist for formation. And I was talking about checklist formation to be followed by blinding. That's item different one here. And then I wrote first off I left it to you, but I let me repeat. Has formation approximately reached which can be checked by reduced levels? We can and make sure that we have reached that level approximately, not more than that, maybe a little less, so that it can be covered in dressing of formation. Now, is reduced level applicable to formation level or to formation blinding bottom level? We have to make sure this. We have to just make a check. Then, has factual SPC, which stands for safe bearing capacity, been confirmed either by plate load test or by some other method, applicable load test? That we have to make sure, and we have to do it in field. Means it's not simply saying, means we have to confirm it if it's required. We have to conduct load test by bringing some truck in, putting a plate squares 30 by 30 plate on that, and we have to make test for that. Whether formation is water, ice and moist condition, we can know it from our own experience by view. Water exists or moisture exists or is dry, and the soil show dry area conditions that we have to understand. Now, watering, dewatering activity being continuously working, if so applicable, means we should have known in beginning before starting excavation states of water table, and if we have to apply water dewatering system, it may be well point system or it may be submersible pump system or some other system, which depends on type of soil underneath. If say silty clay, we cannot say that we can go for submersible pumps, and if it is for sandy soil, we cannot say we should go for well point system. Depends what we have to do. We'll talk later on in watering, but it's also important that what we have to do. We have to assess which method we should either have soil investigation report, or we can know by some other experience or nature of soil. When we have made some pit, we know it's clay soil or it's sand soil, depending on type of soil, because sand soil allows permeability, whereas clay soil is porous. It does not allow any permeability. So, in absence of permeability property, there is no way that water can flow on its own under pressure. It shall remain in pores, and soil will swell. So dewatering depends on that. In well point system, water flow is very limited. It comes in very small quantity, but when you consider sand soils or other soils, non-clay soils, for example, rocks or something, when water comes in, then it's different type of flow. So we have to think, we have to decide this. Dewatering is a must if it is there, because you have to keep area dry. You cannot work in wet area in foundations. As field density test at foundation we will conduct, so I say field density test we have to conduct before doing everything, and whether or not it may be consolidated before, but density test compaction is a must before doing formation. Does soil need improvement either by replacement or by some other stably optimized method? Soil improvement, if applicable particularly in clay soil or silty clay soil, which are not accepted as good soil for purpose of foundation structurally, and they have to think of that. Means should we take out bad soil or unreliable soil to some extent, and then we have to replace that excavated soil with graded soil or graded material layer. That depends. Means we can decide on that as a structural designer, or you can say geotechnical engineer can think on that, whether or not to improve soil. And if soil needs improvement, either by replacement or by some other suitably optimized method, we should do that. And is soil improvement indicated on project structural drawings? If it is indicated, there is no way you can avoid this. Has shoring been in place during excavation progress? That you have to see. what sort of soil it is. If it's collapsible soil, it's caving soil, caveable soil. We have to provide supports to sides of foundations so that caving is not allowed or not is controlled. Soil supporting system safe for workers, that is for workers, supporting system safe for workers, so that in case of caving they should not be buried conveniently. Compaction of foundation formation is required to be compacted. We have to see is it comfortably conveniently done. In corners particularly where even your you can say compactor cannot reach, and in some cases jumper even cannot reach, that could be possibility. You know what is jumper and what is compactor plate, compactor and jumper, you know that. Soil condition is soil condition indicating stronger soil than as specified. What do you think? You have to see, you have to observe its condition of soil. What you expect it should be, is that stronger than that or it's weaker than that? And stronger than that, you think so. Then can you raise foundation? That's point. Raise means if you have to go say for 1.5 meter, 1 to 2 meter, can it keep it a little higher if you design wise it is safe? Because existing soil is consolidated. Don't forget, it's maybe rock. It's having a natural strength, and it's no meaning in disturbing consolidated portion. It means it's not always very common, it's not very general, but in case you think unexpected strata is available, you should use that rather than excavate for nothing. And if it can keep building foundation is stable, in that case we can propose to raise some foundations to some level higher than was expected or was planned. And so we may have to redesign that. Doesn't matter, redesigning doesn't take much time. It's not very complicated. Of course, you can make saving from excavation, and particularly if it's rock area where it takes time to excavate, and we have to make use of that strength of foundation, good soil. So we have to make sure, we have to question, is it economical to recommend redesign of foundation? Can equipment safely move to formation and work efficiently for various purposes? All equipment. Have various grids been erected in place temporarily? Various grids been erected in place temporarily for verification of structural axis, and we have to make arrangements externally for all grids, x-axis, y-axis, so the excavation be done comfortably, and these locations, these survey points in form of grids or in form of kind of railing around with pegs, all grids are written ABC or 1, 2, 3. They are all reference points for permanent work till foundations are completed and even work is taken to higher floors. Then have various grids been erected in place temporarily for verification of structural access. If soil improvement is not required, can blinding preparatory works move? That will decide. Now checklist for blinding, item number 4. This checklist for blinding. Blinding, first of all, be clear what is blinding. There is no eyes that are blinded here. When you say blinding, this means there's some unevenness in ground, undulations in ground, no potholes, undulations I'm talking, and it is compacted formation, but not exactly same level, could be a little different. Maybe some rebound soil, some you can say small valleys, non-straight lines. There can be anything, but there's no disturbance to formation soil strength. It's compacted one with FTD cleared, and we have to do concrete on that in thin layer, concrete on that thin layer. And also if some termite treatment termite treatment is allowed to be done, we can do that before we lay blinding concrete. Ensure formation is well prepared. Whether or not anti-termite treatment is specified, if required, apply treatment through specialist applicator. Marking of blinding areas, batten forms of lines of areas duly fixed, batten forms of lines of areas duly fixed. At in bottom I'm talking, this is formation level, very small, it may be 50 mm, 75 mm, not more than 100 mm maximum. Generally 75 mm, that you have to put some buttons for sides, maybe 3 inches by 2 inches section timber, or some other arrangement which allows formation. Arrangement of blinding top profile, that's important. Profile means to what level you have to put some marks there before concreting, and you have to finish concrete at that level, top of blinding concrete. Arrangement of blinding top profile, whether or not blinding pour is by RMC, that's ready mix concrete, and if so, whether or not pump is required. Concrete pump, I mean to say, it's better if you get concrete pump in areas which are remote from. We can do fast this binding concrete instead of taking by temper or by manual methods. If you have pump, you can do it fast. Of course, it should be low slump concrete, not very high slump, to make sure that pumping may not be difficult. Ensure required strength of concrete pour gang, means whatever gang you have, it should be crew you have, you can say gang or crew. Ensure required strength of concrete pour gang. Ensure post concrete curing arrangements, because you have to cure concrete, though it's not considered very structural concrete, but concrete is concrete, structure no structure. It has to be well developed, it has to be well strong, required strong, and that will be achieved only by curing. Or you use curing compound, it's up to you, but if you want to work quickly on this, then better you do it manually. Manual curing. Then you can say ensure tools for smooth finish are available. Lining is done on that, waterproofing is done on that. So you have to make, you have to also to make layout, WL layout in that. So ensure, you can say, post, tools for smooth finish are available. Then plan sequence of pour of your concrete blinding, how you want to pour that. That's not very, it's not construction design, in fact, it's just way. Because there's no structural concrete, it's just base concrete. You have to start actual work on that, structural work. Then you can say sequence of pour, and then you have to say plan pump locations. Yes, best one. If one location can cover all, or you have to shift pump twice. Well, it depends on site requirement and whatever plot you have diagonally. You can see if you are going to do whole blinding once, or you are going to patches. So plan pump locations, plan concrete delivery frequency, because you are not going to do hundreds and thousands of people to concrete in this very small quantity, probably thickness are small. So you have to see what speed of concrete this ready mix has to say deliver to you. If after all you are doing with pump, you are doing with crane, it's different. You have to think, ensure that pour is not unreasonably delayed when anti-termite treatment is applied. You have to cover that treatment as soon as possible in a couple of days. Ensure that area is constantly kept dry. That's it. Means when they go to checklist for concrete protection, waterproofing item 5. Waterproofing item 5 is checklist for concrete protection. Waterproofing. First of all, we have to understand what is waterproofing here. I explained many times, so even then there are instances some people not clear about that. Waterproofing. Waterproofing here is is something we can say. In fact, it is not waterproofing. Term itself is confusing. Itself is confusing, this term. It's not exactly waterproofing, but it's protection to concrete surface. In foundation you have sometimes footings, then stuck columns. You have sometimes raft foundation. You have sometimes combined footings. You have sometimes piling, and you have sometimes only beams. Whatever be case, all have to be merged in soil, and soil means soil contact with concrete surface. Soil permanent contact with concrete surface. And nature of soil keeps on changing depending on movement of material within soil. Soil has its own composition, but soil is not, you know, you can say impervious. Soil allows porosity as well as permeability. So there are chances in future that soil particles, if are very fine, can mix up with water, and water flows in soil underneath, and it flows with whatever coefficient of permeability or whatever it moves in. It moves in very slow indeed, yet it moves slow. It can bring with it chemicals, minerals, it can bring with it soil particles, and not only from this building, it can move from others as well, and from this building it can move to others buildings. Now those chemicals in soil or minerals in soil and particles of soil itself, they have different unknown chemicals in them, unknown impurities which can harm your surface of foundation. Then foundation, so water mobility, I call it water mobility, is very dangerous. It doesn't happen immediately. It takes months and years to pass from one point to other point. But it disturbs whole areas, of course, to very minute concentration. But that minute constituents can cause caving or upheaval. That point we have to keep in mind. So, concrete protection purposes, that your structural surface should not be adversely impacted upon by such impact of water soil on foundation. For that purpose, we create one barrier between all surfaces in foundation, what is horizontal, vertical, above blending, and wrap them completely. A kind of wrap, you may say. I'm saying horizontal surfaces and vertical surfaces up to plinth level, you may say up to ground level. That two can take together. Two can take together. That's the important point here. So you are going to apply this waterproofing membrane, either cold application or by hot application, torch application, or by other way, completely covering your vertical sides and horizontal portions and all foundations, whatever is there, and then starting your ground floor activity. Then we say ensure that blinding is well cured for minimum of 3 days. Blinding concrete is well cured for a minimum of 3 days. Ensure whether or not surface is smooth. Apply repairs if required. Ensure all battens or forms removed, whether it is cold or it is hot application. Can specialist application be proceeded? Checklist for foundation, footings, preparatory works, item under 1.6. Checklist for foundation. Checklist for foundation. Now ensure whether or not protection applied on concrete. We just talked about concrete protection. Ensure setting out for foundation in line with drawings. Ensure reinforcing bars are fabricated and assembled. Ensure rebars are fabricated and assembled to specification requirements. Ensure formworks of footings match design. Ensure rebars are properly placed and fixed. Ensure formworks are true to plumb and lines. Ensure concrete spaces, whether plastic or concrete mix, are placed well. Ensure whether or not cathodic protection required. Provide if so required, followed by continuity check. Check footings alignments better in grid reference. Check footing top levels. Check supporting system for formwork sides. Ensure concrete protection is not damaged during preparatory works. Make sure that a safe access to all footings and a strong working platform for crew or workers and vibrator is erected before inspection for pouring concrete is conducted. Check water hose pipe is available to all foundations. Check curing arrangements are made available specific for concrete covers. In certain cases, thicker cover is specified for stub columns portions, for which extra size of stub need executed. Got my point? I'll explain. Ensure that care is taken thereof for construction joint. Foundation, footings, preparatory works. As I explained before, temporary works, preparatory works, permanent works. Now we are talking of temporary as well as preparatory works. Say this is for foundation, footings. Whether or not protection applied or concrete protection, you know it now that protection is applied, that you have to see on blinding concrete we have done. So we have to see protection is available, applied or not on blinding work, and then we have to start further, because we have to keep margin for vertical portions also when we apply on concrete protection on blinding. Setting out you have to do for erecting shuttering or formwork, and that setting out you have to do every time in line with drawings. Then C, reinforcement bars are fabricated and assembled according to specification requirements and to drawings. BBS you may call it, binding or binding schedule. It may be 4466 BS or 8866, whatever you do it or your own, it doesn't matter, you follow BS, I'm not saying that, it's wrong. Methods should be according to details, you can say assembled, fabricated, or when I say fabricated means cutting and placing, cutting and bending, and then assembly means placing to required positions according to specification. When formworks of footings match design, you have to make sure whatever work you do to design means sizes, height. Then reinforcing bars are properly placed and fixed, you know that using note. And formwork should be true to plumb and lines. Then concrete spaces, when you say concrete spaces, concrete cover blocks, you can say concrete spaces. Whether plastic made or concrete produced are placed well, fixed well. And cathodic protection is a question mark here, whether or not cathodic protection requires cathodic protection, you know this. And if there is a small help to you, that corrosion is very easy to occur on steel surfaces. And where steel surfaces, steel bars, reinforcing bars. It's not suggested that you use rusted bar. First of all, we don't allow rusted bars. Whatever rust is there should be removed by whatever method, or there's a protection to steel bar storage every day or time under polythene cover. And bars are stored above ground level to whatever level. You have to make some platform so water should receive immediately once it's in contact with ground. And you can say cathodic protection here is you have an arrangement in this steel to provide that all these bars are connected to some anode. Anode is placed at site on this foundation. If it is continuous steel in top and bottom of foundation, there is a wire, specific wire with clamps in this C clamps. These are put in every bar and wire moves around, and it covers each and every bar continuously from top to bottom and up again. That is connected to one boss in external position. All these wires and clamps shall be embedded in concrete. You cannot weave them later on, and later on you cannot weave, but this boss, we call it boss, conical boss, is fixed in concrete where this will be exposed. And if it happens that this point we have to understand about cathodic protection, this very important point. We have to provide anode on site in member we are going to treat with, and there is a cathodic control at remote. So I'm talking about plants, where it's generally done, big plants. This cathodic center is controlled by remote, and whatever rusting or oxidation happens on steel bars means is development of corrosion that's pulled from cathodic controls, and sacrificial anodes are fixed in concrete and site, which is called critical weather of section. We must understand this point. If you have corrosion control on your concrete work, this is way that you use. This is called critical control. Sometimes 2 or 3 such controls are fixed on major foundations, and depending on electrical technology they decide what should be done. Or non-critical foundation, just one boss is fixed in stub columns or superstructure column and is wired out. So there are critical cases and subcritical cases, both ways. So this is specific point of corrosion protection, which is generally taken in plants life because corrosion is not acceptable. But here people do not think about this at all, and they put steel parts in water itself. I'm sorry to say that. So cathodic protection is very important item. And if you are going to use epoxy coated bars, so there is no question of corrosion. But remember, in epoxy coated bars, corrosion cannot be controlled. You cannot apply cathodic protection. So where you are going to use protection in your work building. So after cathodic protection we go further, because this was very important point we had to consider. Provide if so required following by continuity check, as I explained. Check footings, alignments better in grid references. Now alignments you have to check before concreting, and axis of your footing and axis grid should be same, there should be no difference. So alignment is a must. Grid reference should meet according to drawings. Check footings alignments better in grid references. Check footing top levels. You can check them because you have to concrete up to that level. So you have to fix some points on concrete shutters or somewhere else in term forms of whatever way, so that finishing mission after compaction is done, vibrator is applied, finishing has to be done up to that level. So this is called alignment better in grid references. And check footing top levels. Check supporting system for formwork sides. Supporting system we have to check because there are chances when you use pump it falls with speed, concrete falls with speed, and when it's to some level or full, there's pressure is built up and your sides verticals can open, destroying all work. So you have to check supports and system of all sides of foundations. Sides used. Then you can say check supporting system of scandlings or whatever you have. Of course, there is not much pressure, but pressure is expected, whatever it is. Why let it be opened? And ensure concrete protection is not damaged. During preparatory works, concrete protection is required before blinding. Let it remain intact. That's point is you have to be safe about that. Make sure that safe access to all footings, and strong working platform for workers and crews, and vibrator is erected before inspection for pouring concrete. It's a very complicated one, that safe access is temporary work. Safe access is temporary work, but it's safety related. For footings you have to go and down in pit, then a strong working platform where you have to work, that's also temporary work. The strong working platform, people stay on that, crews stay on that, vibrator is also available. There's dynamic motion there, people are walking here and there, and also vibrations transferred from vibrator use near your footing, and for crew standing, crew use, vibrator is erected before inspection for pouring concrete. So then we can say check water hose. Check water hose pipe is available to all foundations, because you have to clean them before pouring. And check curing arrangements are made available. Immediately you have to start curing after concrete is finished. And then you can say specific for concrete covers. This is in certain cases thick covers are specified for stuck columns, portion for which extra size of stuck need executed. Ensure that care is taken thereof for firm construction joint. So what is this point is very, very simple. That steady column. Then you can say concrete covers. And I also said that a thick cover is specified for some stuck columns. Why? In major footing, sometimes it is given a foundation concrete with 50 mm cover, and overlap in those is not permissible because of diameter of pipes. Or is permissible also, if it's permissible, if there's no without mechanical connectors. So, but position of column still should be right one, because it's going to take superstructural columns further. So what we do, sometimes we keep bars in position, and then Then we say that we have prepared for footing, we have to check supporting system, and then ensure concrete protection is not damaged during preparatory work, and make sure that safe access to all footings and strong working platform for workers crews available, which can do pouring concrete. Before that, check water hose pipe is available. It's all essentials, and curing arrangements are made available. And we know we have to provide a thicker cover in foundation, and for that we can, in that portion where stub columns are coming in, we can make size concrete more than, so that bar remains in position and cover of thicker cover is used in that stub portion, and normal size of is a section starts from plinth level or grade level, you can say. So thicker cover is applied there, and this is what about you can say foundations, and we have to pour them, which will take later on. Pouring we'll consider later on. And now checklist for stub columns preparatory works, and that is item number 7. Now we are doing stubs before we did formation. Now setting out for stub columns in line with drawings requirements. Reinforcing bars are fabricated and assembled to specification requirements. Bars are properly placed, fixed and cleaned. Proper touch-up paint applied if epoxy coated bars are used. If so, it's conditional, it's not mandatory. If epoxy coated bars are used, you have to apply touch-up paint. And also construction joint is correctly scabbled or chipped or hacked. Construction joint is correctly scabbled or checked, you can say, or chipped or hacked. You can say. It's not, construction joint is correctly scabbled or chipped or hacked. Ensure proper concrete covers are installed, duly tied up. Concrete covers are installed duly tied up means there should be no loose cover. It should be fixed between a bar to which fixed and surface of shutters. It should not be loose, otherwise there is no meaning of this. It's not fixed with shutters. It should be between shutters, foam surface and bar. Otherwise it's meaningless. Then construction joint is correctly scabbled or chipped or hacked. Construction joints means where you have left your footing and we have to start stub. That is called construction joint preparation. Scabble it, chip it and remove all latins from there. Clean it completely and also remove if any stains are there of concrete on your steel. So brush it out with steel brush. And proper concrete covers are installed to be tied up. Formwork is in line to all directions, and well secured. Forms are all set in plumb on lines, all sides to make a base for upper forms. Whether or not you have to see make sure whether or not plinth or other beams preparatory works to be monolithic or otherwise, means there are certain specified on drawings that this beam has to be monolithic, otherwise it doesn't make much difference. But steel dowels are in place. Make sure steel dowels are in place for beams if separate casting has been programmed. because monolithic casting is complicated, it's very difficult for control. So it's because of beam, it's not structural one. Sometimes we can say that okay, you make more construct joint there and leave dowels for that and do it, but it's very complicated, Now make sure steel dowels are in place if separate casting programmed for beams. Also ensure all supports are properly fixed at bottom and at top of stub, if not more than 1200 mm high. Means all supports are fixed properly at bottom and at top of stub, if not more than 1200 mm high. Ensure steel clamps are in place, shikanjas are in place, duly tightened, or tie bolts are fastened well. If not shikanja, then tie bolts. We are talking of now preparatory works. Ensure whether or not pipe sleeves installed for tie bolts passing through column's body. If this tie bolts outside, this problem doesn't exist. Ensure whether or not cathodic protection required. If it's required, you have to do it. If it's required, whether or not it is critical. If it's non-critical, whether bosses and GI wire are available. Check water hose pipe is available to all areas of stubs. Check curing arrangements are made available and make sure that safe access to all stubs and strong working platform or plates for workers and vibrator are in place before inspection for pouring concrete. This is part of temporary work. Make sure that safe access to all stubs and strong working platform or plates for workers and vibrator are in place before conducting inspection for pouring concrete. This point we have to be clear about. We can review this stub column, setting out and rebar fabrication. All these activities are shown here, and we have to go to concrete checklist for backfill works. Now backfill works. Backfill, as I explained before, is very important, very much structural item, though people think it otherwise. This is very much a structural item and it must be taken with full consideration, full seriousness. But it does not happen. It doesn't happen. People take it very lightly and they spoil everything. People leave it to deterioration in future because this can cave in or this can settle further, leaving your structure hung or it's hung, or caved in. Anything is possible if backfill is not done professionally according to requirements. Backfill is very, very important activity in structural engineering, but it's not given due attention because people think it is soil and they don't understand relation between backfill and structure. It's not, and people don't explain, engineers don't explain to them as well. So backfill is taken for granted in our country. I have seen even government projects where you can say high level engineers are available at all levels, high profile engineers, but I have not seen any engineer supervise backfill activities JVCs are brought in and is filled as this is something, just pour in, pour back and come out. That's it, that's done. It's really I cannot say what I should comment on this. I can only say ignorance by engineers and supervisors, and because there is no method technology or method statement available for them to follow up, which is dangerous, very, very dangerous, I can say. So, what to do? It's question mark what to do. Make sure that selected backfill or selected fill or imported fill or desert fill materials are approved. Well, approval is always there. Make sure that recommended additives materials are made available if so required. This is a point here. Additive materials. What is additive material in backfill? Backfill material is approved, that's okay, but how it is approved? It should be approved based on its grading, based on its particle size, and based on its density, which material sample is sent to laboratory. They conduct test on this, they find laboratory density, and they also recommend, if it's not to mark that you mix this much dune sand in this, or this sand in this, or something else in this, or these two different materials can be added in this proportion, so that we can enhance property, density we can enhance, grading we can enhance, and we have to mix properly. That's what it said. Additive materials. Then make sure that stock of backfill materials are located in some reachable place, where we can say backfill material which is excavated, that's available, and some imported material is brought in, and both are mixed in some ratio. So get design backfill material. It's called backfill material design, which achieves that defined property, which would have 98% Proctor or more even in some cases. So if we can do that, that's fine. Or what else recommended by technical engineer. So stocks of backfill materials are located in some reachable place. That's what's said. Then screening of larger particles is well done. More than 75 mm are not accepted in backfill. Though people put builders and others, they don't know what they are doing. They are having lack of information, you can say. So 75 mm or above should be taken out. And then you can say screening of large particles is well done. Proper watering on material is effective for initial mixing. So check whether or not all substructural activities are completed, including blocks or brick works, before starting backfill. You have to check. Not only you have to start backfill, you have to clear, you have to apply waterproofing membrane on surfaces, and protect that membrane. You have to provide something else, flexural sheet or whatever is specified in the method statement, so that when you backfill, your chips which go in soil should not angularly touch your surface of columns or beams or whatsoever. This can puncture that's why flexural sheet of protective cards are allowed. And then all work is done, cleaned, everything is done. Then you have to start other activities like block work or block work. You have to check, make sure that rubbishes and debris are cleaned from area. All debris are cleaned from area. Ensure concrete protection applied on all surfaces and well protected. Bottom portion of shoring removed. And stage of shoring, you know, stages of shoring removal during backfill of progression, stages of shoring removal during backfill progression, backfill approvals, then you can say test checks, field test checks, and all that. Necessary equipment available: shovel, small roller, plate compactor. Number of backfill layers which you have to decide, because maximum in one layer you can place 150 compacted one and 200 uncompacted one. So if it is 100 meter backfill, 100 centimeter backfill, you need 7 layers depending on the 15 into 705. So it depends how many layers, number of backfill layers required, number of field density tests required from every layer depending on criteria fixed for backfill, how many square meter backfill and how many tests for how many square meter applicable if you take one test. Then field density test required, and passes of small roller or plate compactor means how many number of passes you do, so that rebound known. No use if rebound is happening and you just pass on, keep on roller. There's no meaning of that. Once rebound stage reaches, and jumper you have to use for corners where compactor cannot reach, cannot work. This is when you can say this is your backfill operation to start. And meanwhile I also close this because time is over. Today I did talk on some quality issue which is very important for everybody, and this is applicable, and we are doing this for this purpose. It's really interesting to note that if we work on quality, we can do something. If we don't care about quality, then we cannot say that this is engineering work. Quantity is not engineering work. Quantity based on quality is engineering work. So engineering work means quantity work and quality work. Both are infilled, both are followed. Only then it's called quantity or quality based quantity work. We must understand this point. This must be clearly understood by everybody. That's where we play with or don't play with, I cannot say, but it's important role, and engineer has to understand this. And now young engineers must learn quality before asking questions, or before, if you ask every question all time, this means you did not learn anything, or you don't want to read yourself. That's the only purpose I'm trying to give solutions, what they should do. I cannot claim that I am 100% right, but based on my engineering knowledge, based on my practical experience, I can assure that something you have to do for your own, so that it's done well. And with this I can say, let's enjoy quality in practice. Let's enjoy its deep-rooted works. Quality is available, methods are available. If not available is our will. That will we have forgotten. We did not allow that will to come out and help us. That's point we should think of again and again. That will requires to be created. That will doesn't. I don't have, you don't have. Maybe I can say that. Maybe even if I work now on site, people shall not accept me because you are old man. You don't know. What do you know? We have to produce this, we have to produce that. And that detraction, the detraction from quality shall hamper quality work. So I take now your leave. We hope some of you may understand what is quality.